Okay, let's talk about note card 13, odd functions. Odd functions have origin symmetry. So this isn't going to be quite as easy as the even symmetry, but it's not that much more difficult. To determine origin symmetry, basically when you have a graph, it says turn the graph 180 degrees, and if the graph looks the same as the original, then the graph has origin symmetry. So what we have here, if I'm looking at this graph below, which by the way looks like the parent function to y equals x cubed, if I look at this graph and if I imagine it being turned, which is kind of hard to turn the computer upside down, I guess you could, but if I imagine turning this thing upside down, when I do, this graph looks the exact same when I turn it upside down. Because when I turn it, which 180 degrees by the way, means I'm turning it upside down. So if I imagine turning this graph 180 degrees or upside down, then this top right tail here becomes the bottom left tail. So this one will have origin symmetry, and therefore it would be an odd function. You have your note cards in front of you on your note card notebook. Easily turn that upside down, and if it looks the same as it did when it was right side up, then it has odd symmetry. B, the equations. A function is odd provided that f of negative x is equal to negative f of x. And we're going to do this the same way we worked with the even functions. We're going to replace every x with a negative x, and then we're going to simplify. Okay? And if we get the same thing, then basically, well, if we don't get the same, let me just read this. Change the x values to negative x, and then change f of x to negative f of x. Multiply f of x by negative 1. Okay? In the equation. If the new equation equals the original equation, then the origin symmetry exists, and it's going to be an odd function. Okay, so what you want to do is you want to do both things. You want to change x values to negative x, okay, and we want to multiply f of x by negative 1 at the same time. So there's two things that are going to happen here. So if we have example 1, f of x is equal to 4x to the third, the first thing I want to do is I want to replace every x with a negative x. And again, I start by rewriting my function using a set of parentheses everywhere I have an x, and then replacing that x with negative x. Okay, this is the first step. And I'm going to go ahead and simplify this. So negative x to the third is just negative x to the third, because a negative number raised to an odd power is still negative, and times 4. And when I simplify this, the 4 times the negative becomes negative 4x to the third. Now let's stop and think about what we've just done so far. What we've really done with this first step is we've checked for y-axis symmetry from note card 11. Because on note card 12. Is it 11 or 12? I can't remember. 12. Note card 12, y-axis symmetry. Because to check for y-axis symmetry, what we do is we replace every x with a negative x. And then if it comes out the same, then it had y-axis symmetry. Well, you can see that the original to here are not the same, so we do not have y-axis symmetry. So this function is definitely not even. And the reason why I wanted to backtrack and show you the first part of checking for an odd function is the first step, or the only step, in checking for an even function, because you don't have to do this twice. what you're going to be given on the assignment or on a quiz or on a test, it's going to say check to see if this function is even or odd. And so the first thing you would want to do is check to see if it's even. And to check to see if it's even from note card, the previous note card, we just simply plug in a negative x for the x and simplify, and if what we get at the end matches the original, then it's even. Okay? Now to check for what's odd, we simply multiply what we have by negative. Put a negative out front, or by -1. And when I do that, negative times negative is positive, and I get 4x to the third, which matches the original, so I have odd symmetry, and it's an odd function. So again, recapping, to check for even symmetry or an even function, you simply replace each x with a negative x and simplify. If you get what you had at the beginning, then you have an even function with even symmetry. Okay? To check to see if you have an odd function or origin symmetry, or in other words, odd symmetry, then what you do is you take, after you put in a negative x and simplify, then you multiply this answer. Once you get that right here, you multiply that by -1. And if that matches the original, then you have odd symmetry. Let's look at the second example. So the first thing I want to do is basically I'm checking for even symmetry, because I'm just going to plug in a negative x everywhere I have an x. And I start by putting a set of parentheses everywhere I have an x. And then I plug in that x. Now if I give you certain rules or shortcuts, like earlier I was saying a negative number raised to an even power is positive, that's for a reason. This is easy right here. I have a negative number being raised to an even power, so it's going to be even, or I'm sorry, positive. X to the fourth. Negative number raised to an even power is positive. Plus, a negative number raised to an even power is positive. So this matches the original. This has even symmetry, or y-axis symmetry. And I use those terms interchangeably. This has y-axis symmetry, which means it's an even function. But I'm going to go ahead and check for odd or origin symmetry as well. So to do that, I multiply what I have here by -1. Distribute, and I get negative x to the fourth minus x squared, and it does not match the original. Does not match. So it's not odd. Not odd. No origin symmetry. And your note card may be cut off, and so you'll need to possibly copy in these last two little pieces. Okay, so to create a graph of an odd function given some points, it's going to be a lot like creating a graph of an even function. First you want to do is change x and y values of the points to -x and -y. And then graph all the points and connect them to create the function with odd symmetry. So if I create another example like in the previous note card, so if I start off with my x and y values, and again, let's say I have 1, 2, and 3 for x, and 1, 2, and 3 for y. When I plot those, I get 1, 1, 2, 2, and 3, 3. Now what I want to do is I want to change both the x and the y's to negatives and plot those. Negative 1, 1, negative 2, 2, and negative 3, 3. And when I connect these, it makes a straight line. But if you can imagine, or on your paper, when you turn this 180 degrees or turn it upside down, it will look the exact same. We have a function here that has origin symmetry, or in other words, odd symmetry, and it's an odd function.